Okay, today we're going to solve systems of equations algebraically using the elimination method. That means we're going to eliminate either the x or the y. Solve for that and plug it back in. Second page, we are going to solve systems of inequalities by graphing. That means you're going to be shade. You graph both the lines and shade and find where the overlapping shade is. Okay. So let's look at this first example. When we use the elimination method, we want both equations written in standard form. Ax plus by equals c, and a, b, and c are integers. We do not have to have a being greater than 0, which is usually a condition for standard form. Okay, we just need a, b, and c to be integers to make it nice and easy for us. So if they were not integers, we would, let's see if we have any that are not integers. No, we do not. They're all in, oh yes, we do. We have one right here, number 5 and 7. So we multiply that entire equation by 2 to get rid of both those equations by 2 to get rid of the denominator. Okay, so that's what we do to put it into standard form. All right, now we choose to eliminate the x or the y. So if I'm going to eliminate the x's, I need to get the common denominator between 2 and 3, which is 6. That's LCM, lowest common denominator. So in order to, so I'd want one to be positive 6 and one to be negative 6. So when I add them together, I get 0. Well, in order to do that, I have to multiply both equations, don't I? One to get positive 6 and one to get negative 6. I have to multiply both equations. I can do that, but I want to check, is there one I can only multiply one? That's just one less chance for error. If I eliminate the y's, okay, notice the LCM, lowest common multiple, least common multiple is 4. And one's already at 4. So I'd only have to multiply the bottom equation. Since that's a negative 4 already, I'd want the bottom one to become positive 4. So what would I multiply this bottom one by to make it positive 4y? I'd multiply by negative 4. Okay? Then that becomes positive 4y. Then when I add straight down, I get 0 for the y. I'll eliminate the y's. Okay, so that's how I would do it. Okay? And they went ahead and did the exact same thing right here. See, they multiply by negative 4. Okay, and so you get negative 12 plus 2 is negative 10x. Obviously, negative 4y plus 4y is 0. And I have negative 4 times negative 24 is 96. Minus the 26 is 70, as you see right here. Last step, divide each side by negative 10. 70 divided by negative 10 is negative 7. So x is negative 7. Okay, remember we now have to solve for the y. So I plug the y into either equation. It doesn't matter which one. Your choice. They chose to do 2x minus 4y equals negative 26. Okay, that's usually, it says, well, it doesn't matter. Okay, because it's going to work in both. So whatever one you found easier, I would go ahead and do that one. Because if I want to solve for y, can I just add the y across and I get y equals negative 3x minus 24. Okay, so I'm going to plug negative 7 into there. Okay, so now I have y equals negative 3 times negative 7 minus 24. And 21 minus 24 is negative 3. Oh, sorry, it was negative y. Dang it. So that's where I blew it there. That's negative y. Since negative y, I'm moving this across and adding this across. So I have y equals 3x plus 24. Now I plug the negative 7 into there. And I get y equals 3 times negative 7 plus 24. Negative 21 plus 24 is positive 3. And there's my answer. Okay, and then I go ahead and check it in the other one. So I plug negative 7. 2 times negative 7 is negative 14. Negative 4 times positive 3 is negative 12. And negative 14 minus 12 is negative 26. And there's my check. If it works in both, we already checked the bottom one. We solved for the bottom one, so we know it works there. If it works in both, so I go check that one. Guaranteed I have it right. You don't have to wonder. Okay? So there's that example. Let's go to the next one. example 2 here. Come on, move it up here. Okay. Now in this one, notice I either get to 15 for the x's or 6. So in both cases, I have to multiply both equations. So it doesn't matter. Now, I might go with the 6 since it's a smaller number. Okay, so one's going to be positive 6. Since it's already negative up here, I'm going to make it negative 6. So I'll make this one positive 6. So for the y's, so I have to multiply by 3 here. It makes it negative 6. And multiply by 2 here to make it positive 6. Okay, that's the one they chose to do as well, down here. Okay, so now I have 9x plus 10x is 19x. Obviously 6y minus 6y is 0. And 12 minus 50 is negative 38. And the last step, divided by 19, you get x equals negative 2. So x is negative 2. We're always writing it as a point because we're finding the point of intersection. Plug it back into either one. So I plug it back in the top one. 3 times negative 2 is negative 6 minus 2y equals 4. I'm going to go ahead and move that across to make it 2y equals, subtract the 4 across. Negative 6 minus 4 is negative 10. The last step, divided by 2, and I get negative 5. Okay. They are leaving it with the negative, so you have to remember to divide by negative at the end. As I've taught you, always want the variable coefficient to be positive, so I'm never dividing by negative. Okay, if you get used to that, then whenever you have an inequality, you never have to worry about switching the inequality sign. Because remember, when you divide by an inequality, divide by negative or multiply by negative on an inequality sign, you have to switch the inequality. Well, if your mentality, as I've been teaching you, is always make the coefficient of the variable you're solving for positive, you'll never, so move it to whatever side makes it positive, you'll never have to divide by that negative and have to switch. Remember that rule of switching the inequality. All right, so there's 2 examples there. You get those to practice now. And other side, solve systems of inequalities by graphing. Okay, so go ahead and solve for y. Put it in slope-intercept form if it's not already there. So notice 1, 2 are not in slope-intercept form. So go ahead and solve for y. Put them in slope-intercept form. 4, 5, and 6 already are for you. 7, 8, and 9 are not. Solve for y. Put them in slope-intercept form. Graph the 2 lines. Notice that's an equal sign there, so that's solid. That's not an equal sign, so that's dashed. So write those in there so you don't forget. Grab 1 solid line, 1 dashed line, as you see over here. 2x minus 1, the y-intercept is negative 1, go up 2, right 1, up 2, right 1. There's that line, and that was the solid one. Okay, here we have starting at positive 2 for the y-intercept, and the slope is 1/3. So it means up 1, right 3. Up 1, right 3. There's that line, and it's dashed, as you see there. Now, after you've done that, you got to figure out which region it's in. That's shaded. Okay, so if I take this first one, which is this one, and it says it's below it, less than. So that means it has to be less than. So now it's in one of these 2 regions. It's either in region 2, what they're calling region 2, or region 1. Well, on the second inequality, this one right here, it says it's greater than. So greater than means above. So it could be here or here. Well, where's the overlap? It's in both of them. This area right here. So there's my shaded region. Okay, it has to satisfy both inequalities. Okay, so this red only satisfies 1. This green only satisfies 1. But this red and green satisfy both. That's why it's the shaded region. Okay, so that's how you do this page right here.